All right. Hi, everybody. Good morning or perhaps afternoon. I haven't made my own video in a while. Like all of you, I am at home and my technology here is limited. So I'm using my phone today to make you guys a video because today we have to start talking about trigonometry, one of my favorite subjects in geometry. And I was looking around online for good explanations of trigonometry, and frankly, I like my own explanation the best. So I decided to make you guys a video. Now, trigonometry is a big, long, scary word, and it's probably something that most of you have not learned before. But it's important to keep in mind that it's actually a fairly simple concept. The word trig in trigonometry really just means triangle. And the metry portion here really just means measure. I'll draw a little ruler here. You like that? Okay, triangle, measure. And what we're going to focus on with trigonometry are measurements that we find in right triangles. And specifically, we're going to start to look at the measures of the sides of right triangles, and we'll learn that they become somewhat predictable. Before we get going on this, we do need to talk about one little thing here. And it has to do with the position of different sides and angles in a right triangle. I want you to imagine that you are a little person and you're standing right here at the corner of this lovely right triangle. A right triangle has three sides, of course, and the longest of those sides is always across from the right angle, and we call this the hypotenuse. Now, on a right triangle, the hypotenuse will always be the hypotenuse. That's always its name. But these other two legs, we always just call legs. But I want you to imagine that you're standing here at this point, and this side that's way over here across from you, we're going to refer to this as the opposite side. And this side that's right here, that's right next to you, we're going to refer to this as the adjacent side. And that's important because you're going to hear me use these words opposite and adjacent and hypotenuse to talk about different sides of a right triangle. Now, like I said, the hypotenuse is always the hypotenuse, but the opposite and adjacent could change if you changed where you were standing, right? Maybe you walked over here to this side of the triangle. If you did that, now you're up here. Now, the hypotenuse, like I said, is still the hypotenuse. But now, which side is the opposite side? Over here. And which side is the adjacent side? Well, now that's right here. So when you hear me use these words, opposite and adjacent, it really depends on where we're quote-unquote standing or kind of orienting ourselves within the triangle. And we'll talk about this a little more later. Okay, so what I'd like to do is switch now, and on my website, you'll see a handout that I've posted that's called The Introduction to Trigonometric Ratios. And it looks something like this. It's got a cute giraffe there. It's going to help us out. And so if you are able to, you may want to pause the video here and print this out. If you don't have a printer, you can just kind of watch and follow along with me. What I have in this picture are three overlapping right triangles. We have a smaller one here, we have a medium-sized one here, and we have a large one here. Now, just a moment ago, we talked about opposite and adjacent sides, but it depended on where you were. I called it standing. So I want you guys for this activity to imagine you're standing down here at point A. And what we're going to do to start is I just want to start comparing some side lengths of these different triangles. And so you'll notice below is a table, and we're going to fill in this table, and I'll do the first row for you here. So we're going to look at triangle AEB first, this small triangle here. And we're going to find the length of the opposite leg, the adjacent leg, and the hypotenuse. Now, if I'm standing here at point A, the opposite leg would be EB, right? And so we can just count the grid here, and we would see that this is 6. The adjacent leg is going to be the one that's right next to me, right here. And we can count that grid, and we would see that it has a length of 8. The hypotenuse, of course, is right here across from the right angle. And the hypotenuse, we could use the Pythagorean theorem, and we could use 6 squared plus 8 squared equals x squared, and we could solve for that third side, which you guys know how to do. And trust me when I tell you that you would get 10. Now, these last 3 boxes here are asking for ratios. That's really what trigonometry is about. Trigonometry is about ratios of sides of right triangles. So when I write O over H like this, I'm saying what's the ratio of the opposite side over the hypotenuse? Well, the opposite side was 6, and the hypotenuse was 10. So the ratio is 6 to 10, or if we simplify that, we get 3/5. Adjacent side over the hypotenuse. Well, the adjacent leg was 8, and the hypotenuse is 10. Simplify that, and we get 4/5. O over A, you may have guessed, is the opposite over the adjacent. So that's going to be 6 over 8. And if we simplify that, we will get 3/4. What I'd like you to do right now is pause the video and fill in the rest of this table. Using the triangles above, find the lengths of all these different sides and fill in the ratios. Go ahead and pause now and try that. Okay, if you've paused and now unpaused, you're back here. And let's check and see what you got real quick. I did this prior to this video, so I know that we're going to get 9, 12, and 15 here. And we're going to get 15, 20, and 25 here. And when we start filling in these ratios, hopefully you noticed a pattern emerge. Here we'd have 9 over 15, which is equal to 3/5. And here we'd have 12 over 15, which is equal to 4/5. And here we would have 9 over 12, which is equal to 3/4. Notice that we are getting the same answers. 3/4, 3/4. And if you find these ratios here, you should have ended up with the same thing again. So, what's the point? Well, what we're seeing is that this angle right here, angle A, this is some angle. I don't know what the measure is. It's some angle, but that angle is the same in this small triangle, it's the same in this medium triangle, and it's the same in this big triangle. And I could keep on doing this, and I could make another even larger triangle out here that had this same angle A. And if I found the opposite, the adjacent, and the hypotenuse lengths for that bigger triangle and wrote all these ratios, they would still simplify down to the same thing. So what we learn is that the side lengths of right triangles are predictable. They are in predictable ratios. And we saw this already when you guys did last week special right triangles. That was 2 specific cases where we looked at their ratios. Well, it turns out really that all right triangles, in a sense, are special right triangles because all these ratios are predictable. And so we give these ratios names. So when we find the opposite over the hypotenuse, this is called the sine ratio. And when we find the adjacent over the hypotenuse, this is called the cosine ratio. And when we find the opposite side over the adjacent side, this is called the tangent ratio. Excuse my handwriting there. Now, you may have seen these words before. In particular, if you have a scientific calculator like mine here, you probably at some point noticed these buttons, sin, cos, and tan. That is an abbreviation for sine, cosine, and tangent. And we're going to learn how to use these buttons in just a moment. But before we get to that, I want to share with you an easy way to remember this. A lot of students ask me, how am I supposed to remember that cosine is the adjacent side over the hypotenuse and tangent is opposite over adjacent? That seems like it could be confusing to memorize. I have a little trick for you guys. This is a very famous little mnemonic device that you can use to remember this. So we just learned that if I find the sine, which is abbreviated SIN, of angle A in this diagram, I would be doing the opposite over the hypotenuse. And if I found the cosine of angle A, abbreviated COS, I would put the adjacent side over the hypotenuse. And if I found the tangent ratio at angle A, I would put the opposite side over the adjacent side. Sine is equal to opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse. Tangent is equal to opposite over adjacent. What does that spell? SOHCAHTOA. SOHCAHTOA. This is a nonsensical little phrase that people use to remember their trig ratios. It sounds silly, it kind of is, but it's very famous. If you ask anybody that's learned trig and you say SOHCAHTOA to them, they will know what you're talking about. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Still to this day, when I do trig problems, I will write SOHCAHTOA up in the corner of my paper to help me remember my 3 trig ratios. Okay, I'm going to pause or stop the video here, and I would like you to jump to part 2 of this video, which is going to have me going through the example problems on the back, and we will learn, well, how the heck do we actually use this to solve problems? Okay, go check out video number 2 now.